All right, this lesson we'll be talking about the sine law, and by the end of this lesson we should be able to use the sine law to find the lengths of unknown sides and the measures of unknown angles in a triangle. So this is kind of like what we were doing in the last unit with sine, cos, and tan. We had a triangle, we were using sine, cos, or tan to solve either for the length of an unknown side or the measure of an unknown angle. The difference between that and what we're doing with sine law is that sine, cos, and tan only works for right angle triangles. Sine law applies to any triangle, not just a right angle triangle. So that's why this unit is just called trigonometry, or non-right angle trigonometry, or oblique triangle trigonometry, and unit 1213 was called right angle triangle trigonometry. So that's the big difference. So the sine law, as I just said, applies to any triangle. It can be used to find the lengths of unknown sides or the sizes of unknown angles. And it relates the length of each side in a triangle to the sine of the angle that is opposite. So what this means is that if we've got a triangle here, A, B, and C, I've labeled the vertices, so we've got angle B, angle A, angle C, and we can label the sides small letter A, small letter C, small letter B. The sine law, well, one form of the sine law is going to look like this. It's going to look like A over sine of angle A, B over sine of angle B, and C over sine of angle C. So basically this is like these proportional statements, these proportions that we looked at when we were working with similar triangles. We have a three-term proportion. So the ratio of the length of side A to the sine of angle A is equal to the ratio of the length of side B to the sine of angle B, and the length of side C is which is in turn proportional to the length of side C divided by the sine of angle C. So what we need to know in order to work with the sine law is if we are interested in some side, we need to know something about the opposing angle, the angle across from the triangle. Or, you know, it relates the size of angle A to the length of side A, or the length of side B to the size of angle B. Now, this is our first form here, and this form here with the lengths of the sides A, B, and C in the numerator is easiest to use if you're finding the length of the side. The other form of the sine law is basically the same as this one. It's just all of these ratios are flipped over. So it'd be sine A divided by A, sine B divided by B, the length of side B, sine C, so the sine of angle C divided by the length of side C. This form is a little bit easier to use if you are solving for an unknown angle. In actual fact, you can use either form to either solve for a side or solve for an angle. Choosing the appropriate one, though, just makes the algebra a little bit easier. So let's take a look at a question here involving a triangle. We're going to solve this using the sine law. So they're asking us here, we actually have two questions we're going to do here. Find the length of the unknown side in each triangle. So in this first triangle here, we want to find the length of side A. It is our unknown. Okay, and just for convenience sake, we're going to label all of the other sides here. Side A is already labeled. This would be side C over here. This would be side B over here. Okay. And they give us two of the angles in our triangle here. They give us that, and we don't know what angle C is. Now, we could right away figure out what angle C is. Angle C is just going to be 180 minus 65 degrees minus 39 degrees. And doing that subtraction, we end up with 76 degrees. So if we wanted to, we could add that onto our diagram here, 76 degrees. All right, we are solving for this unknown side here, side A. So let's set up our sine law. A over sine A. We're putting the thing that we're trying to solve for up in the numerator. B over sine B equals C over sine C. And just like we did when we were working with sine, cosine, tan, let's start filling in our given information. We don't know what A is. That's the thing that we're trying to find. I'm just going to highlight it again. That's what we're solving for. But we know what angle A is, so we can fill in that angle A is 39 degrees. The length of side B is 30 feet, so we'll just put 30 here. Angle B is 65 degrees. So on the bottom there, sine of 65 degrees. And then C, we don't know the length of side C. We do know that angle C is 76 degrees, so we'll put that in there. Now, just like when we were working with similar triangles, in order to solve this proportion, or to solve for A here, we don't need all three of these terms. We only need two of them. So I am going to sort of ignore this term altogether because it doesn't have all of the numbers filled in for it because we don't know what C is. We want to keep this first one here because it has the A that we're solving for, and we want to keep the second one, the one beside it here, because it has both the numerator and the denominator filled in. So we just need to solve for A, and we're going to do this by cross multiplying, just like we did with our similar triangles. And we only have to cross multiply once, or just multiply across the equal sign, because that'll get us A all by itself, and then we'll have 30 times sine 39 degrees up in the numerator divided by sine of 65 degrees. Now, if we're really good, we can punch all of this into our calculator all at once. What you might want to do first is punch in 30 times sine 39 and then hit equals. What should show up after you hit that equals sign is 18.8796 and probably some other numbers after that. Then do divide and divide it by sine 65. Or you could break the calculation into two parts. We already know what the numerator is. Our denominator is going to be whatever sine of 65 is, so we could punch that in, 0.9063, and then do that division. 18.8796 divided by 0.9063 will get us 20.83. So that's our final answer, 20.83 feet. So if you're doing these intermediate calculations, you want to use 4 decimal places, like I've done here. Your final answer could be 1 decimal place, or it could be 2 decimal places. Okay. So let's take a look at a second example down here, where again, we are still solving for the length of an unknown side. And the unknown side that we want to solve for here is side E. Okay, so we've got E. We've got angle E across from it. We have got angle F. We don't know what side F is over here, and side D is down here. We can figure out what angle D is going to be. Angle D is going to be 180 degrees minus 72 degrees minus 49 degrees. That is going to work out to be 59 degrees. So let's add that to our diagram for angle D. All right, and then let's set up our sine law here. We're solving for E, so we're going to put E up in the numerator. We're going to have sine of angle E underneath it, and then the other terms are going to be D over sine D and F over sine of angle F. Let's fill in what we know. E is the thing that we are solving for, so we won't be able to fill that in. But we do know what angle E is. Angle E is 49 degrees. So sine of 49 degrees. Side D is 57 meters. And angle D is 59 degrees. All right. And then I don't even have to go any further than this because already I can see that I have enough to solve for angle E. I know side E. I've got the denominator, sine 49, and I've got this other ratio where I know both the side and the angle. So I can just multiply across my equal sign, and I will get that E is equal to 57 times sine 49 degrees divided by the sine of 59 degrees. And I can break this calculation into two steps again. 57 times sine 49. If I hit equal sign after that, my numerator is going to be 43.0184. And if I just do the denominator, sine 59 degrees, 0.8571. Dividing those two things gets me a value of E of 50.19, and the units are meters. So that's the length of that unknown side. All right, we'll do one last example here, where instead of solving for a side, we are going to solve for the measure of an unknown angle. So we want to solve here for angle C. Since we're solving for an angle, we're going to set up our sine law with the angles up in the numerator. Sine A over A, sine B over B, sine C over side C. And let's fill in our given information here. C is the thing that we are trying to solve for, so it's going to be blank. The side across from it, this is going to be side C, so that is going to be of a length of 5. B, my goodness, we don't know angle B and we don't know side B, so we're just going to have to leave this as sine B and just B. And then for A, we know that side A, this was side B, side A here is 4, and angle A, sine 47 degrees. Okay, so to solve, I only need 2 of the terms in this proportion. So I can see that I'm going to ignore this one because I don't know either angle B or side B. So the proportion I have to solve, just rewriting this, looks like this. And again, just like we did when we were solving for a side, we're just going to multiply across that equal sign. So I'm going to end up with 5 times sine 47 degrees divided by 4. And that's going to equal sine of angle C. So just punching 5 times sine 47 degrees, then hitting equals in my calculator, and then dividing by 4, I'm going to get 0.9142 is equal to sine C. Now, this isn't my final answer. We don't want to find sine of angle C, we want to find angle C. So just like when we were working with sine, cos, and tan, if we're solving for an angle, okay, our last step is going to involve using one of those inverse trig functions. So in this case, inverse sine. So we want to do the inverse sine of 0.9142, and that is going to be equal to angle C. So angle C, punching this into our calculator, is going to be 66 degrees. So our method is similar, whether we're solving for a side or an angle. All right, we set up our sine law, we fill in our given information. We are going to multiply across that equal sign. Okay? If we're solving for an angle, we have this final step here where we have to do the inverse sine to get the angle that we want. But if we're solving for a side, we are going to, multiply across the equal sign. And then that's all we have to do is just do that multiplication across, and then evaluate, and that'll give us our final answer.